Okay, in the interest of time, we are going to start this session, which is on health risk of and for food systems. This afternoon, we are very privileged to have 5 speakers who will give their presentations, and this include Morgan Benzoki, Gwen Lucy, Reginald Anan, Rosemary Tegekaya, and Habib Adam. We are told that one of them, I think is Habib, will give his presentation online. The presentation will be 10 minutes. We expect each presenter to stick to that. 1 or 2 minutes before the 10 minutes are done, they will be given a sign to tell them that they have to wrap up their presentation. They'll all present, and at the end of the presentation, we ask them to sit in these chairs so that you hammer them with all the questions that you'll have. Okay, good. So I don't know whether I have introduced myself. My name is George Pregod. I'm a scientist from the National Institute of Medical Research here in Dar es Salaam. So we are going to start with Morgan. Welcome.
Thank you for the introduction. We explore the spatial temporal variations in heat exposure across Kenya's outdoor food markets and assess associations with food availability during a market census. I'd like to begin by acknowledging my co-authors and our funders. Global warming poses a serious risk to food systems, with rising temperatures projected to reduce crop yields, particularly near the equator. While much research focuses on temperature and food production, little is known about how temperature affects food markets, where consumers interact with their food system. Most people in Kenya rely on outdoor food markets, where dense infrastructure, limited green space, and customer congregation may precipitate heat island effects with markets warmer than nearby areas. Temperature can be assessed in various ways, with different measures assessing related but different components of temperature. Ambient air temperature is the surrounding air temperature often found on your weather applications. Land surface temperature represents heat radiated from Earth's surface. It's measured using remote sensing satellites that offer free longitudinal data to be able to analyze the nonlinear and constantly evolving trends of climate change. Human heat exposure uses ground-based data to measure the heat experienced by an individual. It accounts for land surface and ambient temperatures, relative humidity, and airflow. Heat exposure is a better indicator of the adverse human health effects than land surface temperature. However, it requires costly equipment and careful monitoring, reducing its practicality for global and longitudinal data collection. If land surface temperature can accurately reflect heat exposure and variations in food access, satellites can be used to monitor market heat trends without extensive data collection. We relate land surface temperature to measures of human heat exposure and to food availability and prices in Kenya's outdoor food markets. As part of the External Food Environment Surveillance System, we conducted a food market census across an urban to rural gradient in secondary cities of Kirinyaga and Machakos, Kenya, from 4 to 7 p.m. during the 2024 dry season. Data was collected on food availability, prices, and vendor characteristics such as age, gender, and infrastructure. Data collectors were heat sensors to measure human heat exposure using ground-based ambient air temperature and relative humidity. Weather data was obtained from the nearest station, and Landsat 9 thermal images were used to calculate land surface temperature and refined using normalized difference indices and land cover. Food vendor geotags were mapped onto thermal maps, and spatial analysis was used to explore the relationship between food availability and prices with temperature. Urban markets were in dense built areas. These yellow dots indicate where the food vendors were located. The urban vendors operated from various semi-formal structures and often specialized in specific items, clustering near similar vendors. Peri-urban markets were located in areas with mixed vegetation and infrastructure, often along major roads. These vendors, on average, operated from more of a fixed structure with 4 walls and a roof, mainly selling packaged snacks and sweets. Rural markets were in areas with more vegetation and minimal infrastructure, mainly in market areas, while few were alongside the roads. These vendors were more informal to semi-permanent structures, often operating on specific days. You can think of something like a market day, and offering diverse goods to meet their consumer demands. Overall, we had data from 6 different markets where we collected data from over 7,000 food vendors. Most operated informally, a third sold from the ground or a bare surface, and a quarter lacked a roof. Many sold perishables like vegetables and animal source foods. We mapped these vendor locations onto thermal maps of a high-resolution representation of land surface temperature. This is a map of one of our counties, Kirinyaga, where the red indicates warmer areas and blue represents cooler areas. The black dots are the vendors, and so zooming in, we can look at the spatial distribution of these vendors across urban markets, peri-urban, as well as rural markets. Vendors were located in areas 1 to 3 degrees warmer than surrounding areas, with strongest effects in urban markets, supporting our hypothesis that outdoor food markets produce a thermal modification. And these markets were not only warmer, but they were unevenly warm. We used over 500 heat sensor observations to measure vendors' heat exposure, which ranged from 21 to 34 degrees Celsius. And for context, temperatures over 25 are considered hazardous, and over 35 pose significant health risk. Ambient air temperatures varied up to 15 degrees across markets, and humidity nearly doubled between some of our locations. Once again, we have 6 different food markets. The temperature that was measured using heat exposure did vary from the data from the local satellite station, as well as land surface temperature, which could be expected because it is measuring different components of temperature. Heat exposure did vary substantially within a single market, up to 11 degrees Celsius. This area-wide map illustrates the variability in heat exposure in one of the sites, urban Machacos, the red indicating relatively warmer areas and blue cooler. Heat exposure was higher in the bus staging area, slightly above average in an open air covered market, and cooler in an area with a slanted roof, which could be a feasible strategy for reducing heat exposure in market areas. Vendors represented by these black dots were located in warmer but not the warmest areas of these markets. However, heat exposure did vary greatly from one market to the next, as well as within that market itself. And this heat exposure was related to the foods that were sold and the prices that they were sold at. Higher heat exposure was associated with a lower odds of selling legumes, grains, and vegetables, but a higher odds of selling sweets. When examining non-communicable disease or NCD, protect, and risk food groups, we found a decreased odds of selling NCD protect foods, shown on the top in green, and an increased odds of selling NCD risk foods, shown in red. However, no relationship was seen with fruits and animal source foods, which could be due to co-founding relationships, due to variables such as cold storage, or because not enough vendors sold these foods to be able to assess these relationships. Associations between temperature and food prices were observed. Higher land surface temperature were associated with lower prices for perishables and nutrient-rich foods, which could be due to reduced prices to prevent spoilage. Food markets can cause heat island effects, making them warmer than surrounding areas. Within these markets, temperatures varied greatly, which were related to food availability and prices of perishable foods. Heat variations suggest microclimates that may reduce access to nutrient-dense foods and reduce food security. While production versus market impact is unclear, combining ground, meteorological, and satellite data can help monitor temperature in outdoor food markets. And this can help us to be able to target climate-smart strategies to reduce heat-related health risk and occupational distress of these informal food vendors. This research provides a foundation for broader application across diverse environments to assess relationships between heat exposure and the healthfulness of diets. Thank you.
Thank you very much, Morgan, for your talk on how changes in temperature affect patterns of food availability in Kenya. Now we're going to move to Gwen Lucy from Food and Agriculture Organization, who will be presenting on the association relations between zoonotic infections and the acute malnutrition in Chad. Again, you have 10 minutes to make your presentation. Thank you.
Okay, good morning, everyone. So my name is Gwenaëlle Luc. I will be presenting on behalf of the team. So my colleague from FAO Chad, a colleague from the Institute of Recherche et Élevage et Développement du Chad, and the Government of Health in Chad. And we will be talking about pathway from herds to child health and how we can address acute malnutrition in Chad. So basically in Chad, what you see here are the IPC for acute malnutrition, and what we are seeing for the past 10 years is all the dry lands colored in red, meaning that we have persistent prevalence of acute malnutrition consistently exceeding the WHO threshold of 15% of children that are acutely malnourished, despite decades of humanitarian effort. Part of the issue is that there is a strong focus in response on immediate drivers or symptoms of acute malnutrition. Most of the humanitarian focus are around food assistance, medical aid, but deeply forget or overlook the basic drivers. What are the systemic causes that then contribute to the persistence of the issue? So looking at the conceptual framework, we were wondering what are the role of livelihood system and what are those systemic drivers like livelihood system, agriculture, obviously, climate, environment, and institution governing those livelihood system. And looking at this framework, what you can see is basically agriculture and livelihood has a broader role than, of course, addressing food insecurity, enabling healthy diet, but also maybe looking at different pathways that livelihood can impact child nutrition, including, for example, enabling a healthier environment by mitigating zoonotic disease risk, especially in agropastoral settings, or for example, can be about women livelihood workload and trying to decrease those workload to enable more better care and feeding practices. What we also know about African dryland, and this is the case for Chad, but this seasonality also applies to all other Sahelian and dryland country, is while we think there is a persistence, actually there is more variation within a year. And what we know about acute malnutrition in drylands, it's deeply shaped by seasonality and by livelihood system. So you can see in Chad, we have two peaks of acute malnutrition. One first peak that happened at the end of the dry season, just before the rainy season, during the pastoralist lean season. Then it gets a bit better, and you have a second peak that is happening just before the harvesting season. And most of the humanitarian focus are very much focused on addressing this second gap, in increasing the crop productivity, access to, and the harvesting. And our project in Chad was trying to find out what are the drivers of this first peak and how can we mitigate them. So basically, from the literature, we know that this is the time when there is a collapse in milk production. Milk is no longer available, especially in a pastoralist community for the children, and it's a crucial source of nutrients. At the same time, basically, it's caused by the decline in livestock productivity and health, and mostly because of scarce access to pasture and to water. This is also the time where the remaining livestock close to the village are also clustered together with the community, relying on the same water sources and sometimes sharing those water sources. And that can also lead to greater zoonotic disease risk. So basically what I will present today is the first part of a three-step or phased project. It's about the formative research we conducted to better understand what is happening during the first peak of acute malnutrition. With regard to, yes, potentially the zoonotic pathogen prevalence and potential transmission to children and their routes. We looked also about the animal productivity, the milk production, and the consumption practices in Kanem and Bahr el Ghazal area of Chad. And we also looked about the livestock management practices and mobility systems around that time of the year. So the second part of this project was more about tailoring the response based on the drivers that were identified and then measuring impact. And for that, we will present tomorrow the result of the impact and this intervention during the side events. So how we did that? So assessing the risk of zoonotic pathogen transmission, basically we used a mixed method approach, looking quantitatively and measuring children nutrition status with anthropometry in different villages, but also trying to understand the presence of zoonotic pathogen. And more specifically, we looked at Brucella, Campylobacter, Cryptosporidium parvum, Salmonella. We also did a separate study on E. coli and total coliform. And we tried to look at it from livestock milk to better understand if there was any possible contamination through milk, especially because during the intervention, the idea was maybe trying to boost the production and consumption of milk while mitigating and making sure that there was no risk associated with higher production and consumption. We also looked at livestock feces, water sources, and more specifically, we conduct an initial survey to better map what are the different sources used by the community at that time of the year and across the day, because sometimes they start with the borehole in the morning, and then when they will go and water the animal, they will use another type of sources. So we wanted to better understand across those different type of sources and across in child feces as well. And qualitatively, we explore through participatory epidemiology what are the diversity of livestock management system in this area of Kanem and Bahr el Ghazal and potential transmission risk. So those are basically some of the results about the zoonotic risk that we were seeing. Basically, we were finding in children high prevalence of Campylobacter. In children feces, we were also seeing and finding more than 12% of children that were also affected and by Cryptosporidium parvum, and more than 43% of the water source were contaminated by Salmonella, including protected borehole. The second thing that we did, and this is a zoom in Kanem and Bahr el Ghazal of Chad, we did to better understand what are the spatial variation in terms of prevalence of of acute malnutrition among children. And basically what we found is, and probably the one that are into a nutrition survey can relate to the high design effect we often see in our smart survey, is that we are seeing that there is a high clustering at village level of acute malnutrition. Some of the villages where we found up to 60% of the children that were affected in some of the villages. In other villages, we found less than 10%. And the methodology, we survey all children in these villages. So it was a full census of all children under 5. What we found as well is that trying to understand what was going on and what can explain this clustering. Basically, the initial thought was, okay, we see maybe higher prevalence in villages that are more pastoralist. In this area, this is very much agro-pastoralist, and there is a certain level of combination between the different production systems, but we were seeing a higher prevalence of acute malnutrition in more pastoralist community. And trying to explain a bit about this heterogeneity, why in the same area that we see in IPC analysis, all colored in red, probably we are missing some specific spatial variation at a more granular level. Basically, we were trying to better understand what are the systemic drivers driving this community clustering. So we looked at access to natural resources in terms of soil quality, in terms of access to water, and basically zooming in this area, while it's considered as the same agroecological livelihood zone, you will see a high difference in access to specific natural resources. Then looking at maybe what are the production system in this area, you will see a different ethnicity, and all of them are among the agropastoralist spectrum, but they are super diversified. And it's basically based on those historical trend of complementarity between more farming and pastoralist community, then that got increasingly affected by climate variability and have to diversify their production system. So some farmer invested highly in goat, some camel herder invested in some and settled on to have some millet. So you had like a diversification of at community level of those different systems, with of course increased competition and conflict over access to those resources. So based on this analysis of different livelihood systems, we have been able to identify that those different livelihood systems and livestock management systems were highly associated with the different risk and routes to contamination by zoonotic disease. So basically, there was some specific, and it was locally linked with where the livestock are kept within the compound or are they kept outside. And based on the production system, there was different livestock management system and different risk. Finally, so just as a conclusion, what we are seeing is this clustering of acute malnutrition is linked to zoonotic risk clustering and highly differ locally based on the agropastoral livelihood specialization and livestock management system. And we understood the need for this integrated livestock management that will look at those different pathways. So obviously having a consideration for livestock productivity, economy, livelihood resilience, but also trying to take in account the possible by keeping the animal during this dry season, mitigating those routes of zoonotic disease. So this is where I'm.
Thank you very much, Gwen, for that very nice session where you have tried to explore the link between the pathogenic infections and the acute malnutrition. That was great talk. Thank you very much. While we're waiting for the other presenters, I think that we can take questions from the two. Okay, are you ready? Okay, people are here. Okay, that's good. That's very good. So are you Reginald? Okay, so we are honored to bring to you Reginald Annan from Kwame Nkrumah University of Science and Technology in Ghana, who will be talking on investigating soil quality, food composition, and human health linkages. Reginald, you have up to 10 minutes, and people will be writing their notes, writing their questions, so that at the end of the presentation, they'll ask you questions. Welcome.
Thank you very much, but a small correction. So I'm Herman Lutrot. My colleague Reginald, unfortunately, could not be with us this week. And so I'll be doing this presentation on behalf of the team. Thank you very much for the opportunity to share some of the work that we've been doing. So investigating soil quality, food composition, and human health linkages. It's very important, and it's a very important initiative that through the Periodic Table of Food Initiative, we are beginning to examine and profile the biomolecular composition of food. And along that line, we are interested not only in what the food contains, but what influences the composition of food and how that composition influences human health. So out of that concept, we try to investigate in Ghana and Ethiopia the linkages between soil composition or soil quality, food composition, and some human health indicators. I'll be presenting some of the preliminary findings from the work that we did in Ghana. Okay. So a couple of images here. In Ghana, one of the pressing issues that we have is mining, specifically illegal artisanal mining, causing a lot of damage to soil and water bodies. So we thought to situate this work to look at whether there are differences in the soil compositions between soils affected by gold mining and soils unaffected by gold mining. And this is a typical image of some of the devastation that this type of mining does to the environment. And then, of course, a group of farmers on their farm. Some of the crops that we looked at, we looked at maize, garden eggs, cassava. These are staples that are consumed in a typical Ghanaian diet. We worked with 60 farmers across 2 regions in Ghana, 2 of the predominantly agricultural regions, the Ashanti region and the Western region. We visited 60 farms and we took 120 soil samples across 2 seasons. So we looked at whether there was seasonal variation in the composition of the soil, the food, and whether it had any impact on human health. We took over 150 food samples as well as close to 140 blood and stool samples, because we're also interested in what happens to the gut microbiota. So this is an outline of the approach that we took. We looked at different physiochemical parameters of the soil, including toxic metal presence and levels within the soil. Then we looked at the nutritional composition of the foods grown on those particular soils. Of course, again, with interest in the toxic metals, as well as the nutritional minerals. And then we looked at serum levels of these heavy metals. And then we also looked at gut microflora. These are the study areas, as I mentioned, from the Ashanti and Western regions of Ghana. A breakdown of the demographic profile of the participants. These are smallholder farmers and farming households that we sampled. Most of them between 30 and 60 years old. Here we present the proximate composition of the food. As expected, there isn't any significant shift in the composition of moisture, ash, crude fiber, fat, and so on. The macronutrients all seem to be within the expected ranges. Now, when we come to the toxic metals, this is where it gets really interesting. We find that just under half of the soils from non-mining areas tested positive for mercury, but over 80% of the soils in the mining areas tested positive for mercury. So clearly there is an impact that mining is having on the mercury levels in the soil. When we look at the food samples that were collected from those soils, 80% of the foods collected from the non-mining areas tested positive for mercury, while all the food samples we collected from the mining area tested positive for mercury. And again, when we looked at the serum presence of mercury in human serum, we found about just under 30% of the serum collected from non-mining communities tested positive for mercury, while 42.9% tested positive for mercury. We did not find any difference between the 2 areas, whether mining or non-mining, in the levels of occurrence of arsenic. Then we went ahead to look at, okay, if the mercury is present, how much of it is there? Maybe it's too small to be concerned. So we looked at the concentrations in the soil. You can see twice the level of mercury in the mining versus the non-mining areas in the soil. significantly more mercury in the foods from the mining areas compared to the food from the non-mining areas, and not a significant difference in the level of mercury in the human samples. Then when it comes to arsenic, although the prevalence did not show any significant difference, the concentrations showed a very, very big difference. So we have in the mining areas, 5.7 milligrams per kilogram of mercury, in the soil, in the mining areas versus just about half of that in the non-mining areas. We find the difference is not that big when it comes to the food, and it's quite negligible when it comes to the human health, the blood samples. Then we also looked at other indicators of soil quality. We looked at the pH of the soil. The pH in the soil from the mining areas was significantly lower, but below 6, while the average soil pH in the non-mining areas was much closer to neutral. This is important because the soil pH has an influence on the ability of crops to uptake minerals from the soil. Acidic soils, up to a certain point, around a pH of 6, facilitates the uptake, especially of iron and calcium from the soil. But when it goes into the region of pH of 5, then it actually hampers mineral absorption while also disrupting the microflora of the soil. Then of course, we looked at the iron levels. We're very interested in the iron levels in the food samples to see if that reflected the levels that we found in the soils. And clearly, there is a significant difference in the iron content with the non-mining areas containing a little bit more iron compared to the mining areas. And then we looked at anemia, and we see clearly that anemia was more prevalent in the mining areas compared to the non-mining area. So the drop in iron level in the food is obviously having an impact on anemia status across these two types of communities. We also looked at microflora, and there's a difference in the microbial gut flora between the different communities, with the samples collected from the mining areas showing lower diversity in terms of gut microflora compared with the non-mining communities. I'll just go straight to the conclusion. So clearly, the mining and the presence of these toxic metals in our soil is having an impact on the quality of the food that we are consuming, as well as on the health of the people consuming these foods. And a lot of the time, these are the same poor smallholder farmers, their families and their communities that suffer the biggest brunt from these occurrences. So, yeah, thank you.
That was a very great presentation, trying to explore the links between contamination of soil with the toxic metals in human health. Thank you very much. I'm sure when we come to questions, people have a lot to ask. So let me now welcome Rosemary Tegaya from the Sokoine University of Agriculture to give us a talk on knowledge and practice on safe organophosphate pesticide use in selected vegetables from Dar es Salaam. Welcome.
Good afternoon, everyone. So I am here to talk about a topic, assessment of farmers' knowledge and practices on safe organophosphate pesticide use in selected vegetables from Ilala in Dar es Salaam. As we all know, a well-balanced diet must contain vegetables. They help to reduce the risk of non-communicable diseases, and as well as they promote public health. Vegetable consumption has highly been emphasized due to their importances, such as they support digestion, they are nutrient powerhouses, as well as they aid in weight management. Pesticide use has been reported in agricultural activities, specifically vegetable cultivation, as the use of pesticide help to rescue vegetable rows up to 100%. And one of the pesticides that has been registered to be used in agriculture as well as vegetable production is organophosphate pesticide. But their use in vegetable production has been associated with different level of human toxicity. We both vegetable consumers are at risk to be exposed to these pesticides, but that is quite different to vegetable farmers since they are exposed twice through vegetable cultivation as well as vegetable consumption. So also their knowledge as well as their practices in pesticide use in vegetable cultivations are very important since they help determine the set of vegetables as well as their quality. So the goal of this study was to assess the knowledge as well as the practices of farmers on safe use of pesticides, on the farmers that cultivate the selected vegetables that we were dealing with, specifically the 3 common consumed vegetables in Tanzania, and that are amaranth, Chinese cabbage, as well as sweet potato leaves. So this cross-sectional study was conducted in 2 wards at Ilala district in Dar es Salaam, particularly Kinyerezi and Gongo Mboto, and 138 vegetable farmers participated in this study. So I will take you guys direct to the key results of this study. Vegetable male farmers took a lead of this study as according to studies, it is a common trend in in Africa, and most of them had formal marriage. And marriages are very important. They help in agricultural decisions, specifically in pesticide use as well as safety practices. Another observation from this study is most of the study participants had low education level. Most of them had only attended primary education, which is turned to be a limiting factors for their knowledge as well as their practices on pesticide use in vegetable cultivations. Now, considering the results on knowledge of respondents related to the pesticides use, 98.53% of the study participants mentioned that they always face or experience pests and diseases infestation during cultivation of these selected vegetables. And the most interested part was they do use pesticides, but they do not seek advices before the use of these chemicals. And one observation that was good from the study group was, but they do buy their pesticide from the authorized sellers, the sellers that have been given the mandate to sell the pesticides. And according to the WHO 2004, they suggested that the only vegetable farmers who are trained on providing the first aid on any incidents of pesticide poisoning exposure are the ones that are supposed to use pesticides on vegetable cultivations. But in this study, the results were so interested as most of the study participants have never received any pesticide training on their vegetable cultivations. Regarding the case of when do they harvest their vegetables for sale or consumptions, 51.47% of the study participants mentioned that they do not know if the pesticide residues may still exist to the vegetables that has been harvested to be either for consumptions or for sale. And most of the study participants mentioned that they are not aware of any health problems that might be caused due to exposure to these pesticide residues. And that is very interesting since most of them have experienced different health problems, while skin itching took the lead for most of the study participants. Now, considering the results on their practices on pesticide use to their vegetable production, Dodocon, which is organophosphate pesticide in nature, was one of the most used pesticides with an active ingredient profenophos. It happened to be the most used pesticide to control pests to the study areas. And when considering if they do read the labels and follow the instructions, that are on the labels of the pesticide containers, most of them mention that they do not understand the labels on the pesticide containers due to knowledge barriers. They mention that most of the labels are written in a foreign language that they cannot understand, so they don't full benefit from the labels. Also, most of them mention that they do not wear the protective gears when applying the pesticide to the vegetables, and that's why most of them mention that their skin do itch after the application of pesticide to the vegetables. Now, considering when do they harvest the vegetables after pesticide application, according to studies, they should harvest their vegetables after pesticide application, either for consumption or sale, just maybe 2 weeks or a week after application. But most of them mention that they do harvest the vegetables after pesticide application for either consumption or for sale, just 7 days before 7 days after the application of the pesticides. And most of them mention that sometimes the pesticide that they use in vegetable production, they are not effective. So to ensure their effectiveness, they do add the dosage so as to facilitate their strength to control the pest or the diseases. Now, on the issue of disposing mechanisms of pesticide use containers and the expired ones, most of them mentioned that they do throw them to the trash, which gives an indication of poor environment, which gives an indication of poor disposing mechanism that can cause environmental pollutions. Now, from the study, there are no significant difference in the farmers' knowledge and practices regarding to different aspects of their social demographic factors, such as age, level of education, sex, years of experience. And from the figures, figure 1 indicates the knowledge and practices level of vegetable farmers, while figure 2 indicates the correlation between knowledge and practices score. And sorry, it was supposed to be in percentage, but only in the case of knowledge, only 9% of the study participants expressed good knowledge, and only 80% of the study participants expressed good practices, while there was positive relationship in farmers' knowledge and their practices, that if their knowledge, they have knowledge, also their practices will be also improved. So that is to conclude that the vegetable farmers from my study area are likely to be exposed to higher levels of pesticide residues due to their poor knowledges. So to do, there's an urgent need of pesticide educations, as well as they are supposed to be trained in order to reduce their levels to be exposed to these particular pesticide residues. And also the monitoring authority of this country should enforce compliances to these pesticide safe regulations so as to reduce exposure of the farmers to this particular pesticide. Thank you.
Thank you, Rosemary, for that nice presentation on use of pesticide in Dar es Salaam. So we are going to have our last talk from Habib Adam. I'm told this is going to be a recorded presentation. If you can have it projected. Thank you. After that, we are going to have a question and answer sessions. The IT.
All right, thank you so much.
Yes, so you're welcome.
All right, thank you so much. So maybe you can proceed. Food systems encompasses all the processes, infrastructure, and activities involved in feeding population, including production and processing, distribution, consumption, and waste management of food, as defined by the Food and Agriculture Organization 2018. They are shaped by environmental, economic, social, and political factors. And their sustainability, impact nutrition, health, and resilience. Now, water quality, on the other hand, and food safety are deeply intertwined elements of sustainable food systems with direct implication for public health, environmental integrity, and socioeconomic equity. Now, water is an integral to multiple stages of the food supply chain, including irrigation, livestock management, food processing, and sanitation. Okay, please, is my screen being changed? Sharing of the slide. Controlling of the slide. Oh, thank you. Thank you. Yeah. So contaminated water sources, whether due to microbial pathogens, chemical pollutants, or emerging contaminants, pose a significant risk to food safety, potentially leading to foodborne illnesses and long-term health complications. Next slide, please. Now, amidst the increasing global concerns such as climate change, population growth, and water scarcity, the quality of water use in food production is receiving heightened scrutiny. Now, links between water quality and food system is more urgent than ever. Now, simultaneously, food safety remains a global priority with an estimated 600 million people falling ill annually due to contaminated food. Next slide. All right, so here we're looking at the interplay between water and food quality. Water quality critically influences the safety and nutritional value of food, contaminated value of food. Contaminated water sources containing pathogens, chemicals, heavy metals, or organic pollutants can compromise both crops and animal products, leading to unsafe food. Now, some of the key aspects of this include agricultural irrigation. Here, water contaminated with pesticides, fertilizers, or other industrial waste introduces hazardous chemicals into food crops. Also, livestock hydration, that is contaminated water, carry pathogens or toxins into animal products like milk, meat, and eggs. Also, during food processing, the use of poor quality water during washing and processing can lead to microbial or chemical contamination. Now, this chemical contamination leads to bioaccumulation of some of them into aquatic organisms, impacting food safety. Next slide. Now, the classes of contaminant in food system. Now, the classes of these contaminants have been grouped into these categories. We have pesticide and herbicide, which are usually from agricultural, from the practice of agriculture, that is application of these chemicals during the production of food. And we also have heavy metals such as lead, cadmium, mercury, and arsenic. They contaminated soil, and due to industrial activities and water pollution, they accumulate in foods, crops, and also in foods. We also have the persistent organic pollutants, which include pesticides, polychlorinated biphenyls, dioxins, and other chemicals resistant to degradation by accumulating through the food chain and causing harm to the consumers. We also have industrial chemicals and additives, contaminants from packaging, processing. They also accidentally find themselves or are being released into food substances and get consumed. The next slide. Also, we have microbial contaminant. This microbial contaminant involves microorganisms such as pathogenic bacteria, such as viruses, parasites. Now, contaminated water, manure, or improper hygiene practices during harvesting and processing lead to presence of Salmonella type A, E. coli, Listeria, and other pathogens in fresh produce and animal products. Also, we have the likes of fungi and mycotoxins, which get into crops through crop storage conditions, which can promote mold growth, leading to mycotoxin production. And such as an example of such is aflatoxin in cereals and nuts. We also can have physical contaminants, which include glass, metal shard, plastics, and wood fragment introduced during processing or packaging of these materials. The next slide. Now, the importance of water quality in food production. Here we said water is a critical input for all stages of food production, from irrigation to processing and preparation. However, poor water quality can cause significant risk to food safety, leading to introduction of harmful contaminants that can threaten human health and environmental health. Yes. So next slide. The importance of water quality and food safety. Now, water quality and food safety are interconnected pillars of sustainable food system. Contaminated water in agriculture introduces microbes and chemicals into food chain. Unsafe water, unsafe food and unsafe water lead to one, public health risks, productivity loss, higher healthcare costs, economic losses for farmers, and environmental sustainability also depend on clean water sources, prevention of runoff and pollution, climate resilient water management. The next slide. Next slide. All right, so the review followed this methodology, such as using the Prisma Preferred Reporting System. Next slide, please. So, pathways on contaminant entry into food system. We've already spoken about some of them. We said yes. So application of pesticides or agricultural chemicals is one of them. We also have food processing and handling. We have airborne deposition. We have water and soil pollution, and we have natural events such as flood and drought can also lead to contaminant entry into food systems. Next slide. Okay, microbial contamination, yes. Well, we have different classes of contamination as we defined earlier. We have microbial contamination, and here multiple studies have highlighted microbial contamination, particularly the E. coli, Salmonella, Listeria, and norovirus. The persistent risk in food system using untreated or poorly managed water.
We are requesting you to
wrap up.
We have 2 minutes left.
Foodborne outbreaks in high and low income countries. Best practices such as food practices, all right, and control, but pathogens such as Salmonella, Listeria, monocytogen, and Sesera coli contaminate food systems via contaminated irrigation water. Poor hygiene in processing and cause contamination at all stages. Contaminated water in agriculture is a key driver of foodborne illnesses, which with outbreaks linked to water contact during irrigation, washing, and performance practices such as cooling. Next slide. Now, also that study reported notable outbreaks, including 2005 breeding case of E. coli in lettuce from river irrigated field, the 2006 California outbreak of E. coli in shredded lettuce linked to nearby contaminated water, and multiple Salmonella outbreaks in mangoes and papayas due to water use for cooling and rinsing. Now, also a study by London et al. 2021 also systematically reviewed the complex interaction between water quality and food system, emphasizing the implication of water and food safety, especially in low and middle income countries. Key points related to water quality and food safety include water use in irrigation, food processing, and food preparation can introduce contaminants into food products, affecting consumer health and safety. Pathogens and toxic substances such as heavy metals and cyanotoxins and pesticides present in water sources can persist.
Yeah, if you can go to your final slide because we are running short of time.
Consumption, causing health risks such as foodborne illnesses and toxins and metal poisoning.
Thank you very much, Habib.
Okay, next slide. All right, thank you.
Okay, thank you very much. Thank you very much. And thank you very much, the audience, for understanding the challenge that we sometimes face with the advances in the information technology. Now we are going to the last part of this session, and it is question and answers. And I'm going to ask the presenters to jump to the chairs and take up their chairs, and Habib to remain online. We have like 15, 20 minutes for people to ask questions, to ask clarifications. Yeah, this is the most important part where we try to join the pieces and bits. Okay. So the presentations are open for discussion or questions. Can I see hands of those who like to ask questions? The first round. Okay, the first 5 questions, 5, 6 questions, please. And when you ask a question, say you please focus it to one of the presenters so that they are aware of who is being asked the question. First 6 questions, please. Okay.
Hi.
Okay, the first. Okay, please go ahead.
Hi, this question is for our colleague from Zambia who's presenting on behalf of his team about the nutrient exposures in the soil and humans. We saw sometimes in your results, the association was reversed, so more concentration of heavy metals or nutrients in the soil compared to the human samples. Could you speak to why that was the case, and also what you make of the results when you saw higher mercury concentrations in the soil, but not seeing that resulting in higher concentration in the blood samples? To get your thoughts on why you think that may be. Thank you.
This question, we want to at least 5, 6 questions before they can respond. That, yes, just keep going. Yeah.
Okay. Sorry, the colleague who is not Reginald. I didn't catch your name. If you can say again. Hema. Heman. Okay, great. Sorry. I had a question of the same, 2 questions actually. One was if you had done any gender disaggregation. I'm interested, especially when you look at some of those outcomes, such as anemia. I wonder if there would be big differences between men and women. And also comparing mining and non-mining areas, I would imagine there might be some dietary differences, so not just soil and so on, but if the diet could explain some of the differences that you see in the individuals themselves.
Next question. Yes.
Hello. Sorry, my question is for the first presenter, Morgan. Excellent, amazing stuff, and really great application of remote sensing data. I can imagine the scalability, incredible. My question was in terms of, and sorry if I missed it in your presentation, in terms of how do we know whether vendors are clustering and locating in areas which are warmer by definition of bus stations because people get off the bus there, versus potentially the market itself being a contributing factor? I don't know if you're looking at causality, if you have already, but no, otherwise, awesome, really cool. Thank you.
Thank you. Next one.
Thank you. My question goes to Heman. Worryingly, I noticed that irrespective of where the food was sampled from exposure to mercury was similar. Not necessarily in the concentration, but exposure, food from mining and non-mining area. And I was just wondering whether an element of traceability was incorporated into your work. Could you tell whether the food that was being sampled from the mining area probably came from mining area, or is it that the Ghanaian soil is just intrinsically laden with mercury? I'm wondering. Thank you.
Thank you. Next one.
Yes, my question is to the lady from the Sokoine University. You spoke about the pesticides that were used on the vegetables to grow food. Is there a case study of what happens to people eat those vegetables as pesticides in the long term? What effects do they face, whether it is children or adults? And another question to the guy from Ghana, Kwame Nkrumah University. In your soil sample, are there no any other minerals apart from mercury that you sampled? Thank you.
Thank you. The last one for this round. Oh, yes, please.
Yeah, thank you very much. So I have two questions. For the first presenter, I'm not. So for the first presenter, I'm not sure on why you took or why you collected data just from 4 to 7, right? Because then I think it really explains your results. Your choice of the time really matters, because then you observe that households reduce, kind of the market vendors don't sell a lot, it kind of reduces, and prices also reduce. But I think it could also be that people decide to go to the market in the morning and not in the evening. So it would have been really good to have kind of a span of a full day in the market to really come out that conclusion that food prices going down and the quantity board is also going down. On the Ghanaian study, really interesting work. Bringing soil health and everything together. And I really like the way you started talking about correlations, but I noticed at the end you rather started talking about causality, like really impacts. And I wanted to get your idea if you think this is like what you did is really causal, because I didn't understand your experiment and I observed what you did as just mean differences. So I wouldn't really call this causal, because then you're not controlling for many confounding factors. You're just looking at households with or without a mining, and then you kind of draw your conclusion. So happy to hear your thoughts on that.
Thank you. That was the first round of the question. We'll start with the presenter from Ghana. You're welcome. And then we'll move up to Rosemary.
Okay. Thank you very much. I have quite a few of the questions. Please, the next round of questions, can you send them this way? Okay. I think the first one was why the disparities among heavy metal levels across soil, food, and the human health samples. All right. So there are a number of factors that influence minerals, including toxic heavy metals. This includes the type of crop. So different crops have different abilities to uptake minerals from the soil. The soil conditions, as we saw, the pH of the soil influences the crop's ability to uptake nutrients. And then the portion of the crop that is edible, it's also important. So some of the crops like cassava, we consume the root, which is directly in the soil, and may be, have greater exposure to the soil conditions vis-a-vis the heavy metals, compared with maybe a crop that we eat, we consume the stem or the fruit or the leaves. So these differences could account for why, even though they are grown in soils with similar levels of heavy metals, the different crops may have different levels of heavy metals. Yes, and then the gender and anemia, yes, certainly. We disaggregated the data by gender. Unfortunately, I didn't present that. But the anemia levels, prevalence was higher among women compared with men. I should mention, however, that our sample was a bit skewed because we sampled more women than men. It was both purposive and convenient sampling. So we sample when we sample the farm, we sample the household that consumes food from that farm. And we find that ultimately there were more women in those households than men. And so that could potentially skew the results, which is probably why I did not present that disaggregation. There was a second part to your question that I missed. Yes, so we actually took diet history as well as dietary diversity data. I didn't present that. We had a whole ton of data. We just carved a small piece for this presentation, but we have that data, and I'll be happy to go into it with you later on if you're interested. Yes, and then the traceability. So we sample the crops directly from the farms. So these are crops that come directly from. So what we did in our sampling was that we picked the farms, we did our zoning, and then once we selected a farm, we sampled the soil from the farm, and then we picked whatever crops were being grown on that farm. So the foods that were analyzed are coming directly from the farms with the soils that we sampled. And if you look at the concentration, so yes, 80% of the food crops showed positive for mercury, but if you look at the concentrations, you find that there's a significant difference, almost a doubling of the concentration between the mining and non-mining areas. So although it appears as if there is a lot of mercury almost everywhere, the levels vary greatly across mining and non-mining areas. And I'm not sure I can explain, but we have in previous studies found some areas, although have no mining activity currently, have very high levels of cadmium. And we perhaps may have to go back into history to find what kinds of activities used to take place in those areas that could have influenced. It could be maybe the type of rocks, rock formation that is there. I don't know if there are any geologists here to help us, but there are a lot of very interesting data that we are unfortunately unable to interpret immediately. But thankfully, with time, we should be able to get more information to help us interpret the data. And then there was one last question on. Okay, I noted it. I can understand how I wrote it. So, if the person who asked can, it was minerals other than mercury. Okay. Oh, right. Okay. So yes. So we did a full profiling of nutrients. So as I mentioned, this is part of the periodic table of food initiative. And so we are very interested in the biochemical profile of all the crops. So we are doing all the nutrients. We have 26 different elements that we're analyzing using ICP-MS. We are doing fatty acid profile. We are doing amino acid profile. To some extent, for some of the crops, we are even doing some metabolomics and so on. So we have a whole gamut of data, including nutrients, minerals, different minerals, iron, mercury, zinc, calcium, and so on. Yes. Thank you.
Yes, I will answer my question that if we considered about the long-term health effects, yes, after we did this study and we gave it a thought, like how about the acute or long-term health effects? So we went back to the field and collected the vegetable samples and we tested them. And surprisingly, even one of the selected vegetables was indigenous vegetables and the pesticide residues were detected. And after we did the risk assessment study and we tested for the acute exposure and for long-term exposure, and we did not detect any acute health effect or health risk on the exposure to the particular residues we detected from our vegetable samples. But we got the result that when a person is exposed to that particular residue that we detected from our vegetable samples, there are possibilities of long-term health effects. Thank you.
First, thank you for those two questions that I did get. they really are hinting towards my future work. So I'm really glad to be able to have been asked them. Starting with the second question, it was why 4 to 7 p.m.? So this is part of a larger study that was looking at the best way to sample informal food vendors. And we have a temporal transect where we collected data from sunrise to sunset. And that work will actually be presented tomorrow by Nulupa Gunaratna. So look in the innovative methods section tomorrow if you really want to hear in depth about why exactly we selected 4 to 7 p.m. But your question in regards to the morning might be different prices, absolutely. We are looking at the differences of our sampling method, and we have the heat sensors on the data collectors for this as well, looking at differences in the food markets between morning and evening, so from 8 a.m. to 11 a.m. and then 4 to 7 p.m. We also are collecting data across different days, so the difference of a weekday versus a weekend day. And then lastly, we're collecting data across seasons as well. So this is a year-long project, and what I presented today is only that first round of data, but we will be able to see how these heat exposure and associations do vary within day, between day, and across season. Along with our future work in regards to maybe food vendors are just located in these areas for other reasons, we're conducting in-depth interviews with the food vendors. So I just got back from training our data collectors. So hopefully we'll be starting those interviews pretty soon. And we're asking them specifically about how heat and cold temperatures are affecting their food vending practices. So we can also understand things like mitigation practices that they might already have in place. And so we're collecting this in-depth interview one time in person, and then we have up to 6 rounds of follow-up interviews that we will be conducting. So we can see if that does vary also based on time, just given there's differences within 6 months of the year on the temperature in the food markets.
Okay, thank you very much. We have very few minutes left, maybe 3 more questions if people still want to. Yes, I can see there are exactly 3 people who want to ask. Please, they should be short to, yes, quick. Stand up and you have this spare mic. Please go ahead.
Yeah, thank you. My name is Khalif. I work for the African Population and Health Research Center in Kenya. And my question goes to Morgan. The work that you did is really good. I want to ride on the work that you did because we are doing some work on improving the food environment. Some of the findings that you reported here are that when there is high heat exposure, you found lower odds of legumes and grains being sold, and also higher odds of sweets being sold. So it appears that when there is high heat exposure, the probability of selling unhealthy foods is higher. So I don't know whether that makes the case for the need to have structured and maybe modern markets where we can have facilities that can keep the foods in maybe lower temperatures. And just to know whether you have published this work and how we can be able to access this. Thank you.
Thank you very much. The next one, please. Long questions are good, but not particularly fitted to this part of the session. So go for short questions.
Thank you. My question is Gwen, and it has to do with the interesting phenomenon you saw of the rise in zoonotic diseases at the end of that first season. And you mentioned it was there was an increase in the animals and an increase in humans. The question I had was whether the concentration of livestock around water was, do you have any evidence that that's actually increasing transmission and incidence in livestock, or is it the proximity of that water body to the human activity that might be increasing what we see in humans in that system?
Thank you. The next question.
Yeah, my name is Tina Manane from Lilongwe University of Agriculture and Natural Resources, Luanda, Malawi. My question goes to the lady from FAO. I didn't capture your name. So I want to find out about the linkages between the microbial hazards that you found in the milk and the child nutrition. Did you come up with any risk pathways or any risk assessment for you to directly link or to attribute these hazards to the nutrition outcomes that you observed? Thank you.
Thank you very much. Let's limit ourselves to those questions and turn to presenters. Please provide short answers because we are really running short of time.
Real quick. Absolutely would love to use the information to develop things like climate smart strategies, having some kind of evidence to establish the need for cold storage. That is my goal. Also, there's other climate smart strategies that are being used in countries like the United States that are things like painting roads or buildings to slightly reduce the amount of heat exposure, which could be ways that could be implemented into the food systems, especially in Eastern Africa. I'm trying to establish the evidence to support that. I don't currently have this work published. There's an abstract in Current Developments of Nutrition, but nothing yet. The data was just collected a couple of months ago, but I'm trying to rapidly get it out because it is something that's very time pertinent, especially in the fact that it's affecting food vendors and their livelihoods.
Thank you. So I will start with the milk contamination question. So yeah, we saw like minimum milk contamination for Brucella only 2%, which was the route we were exploring, trying to see if we were trying to boost the milk production during that season. We wanted to make sure that we are not exposing more the children. So the milk was, the good news is that the milk was the lowest contaminated, and that's why we were exploring other route of contamination, and we were exploring route through water, looking at the different water sources that are used by community during that period. And basically what we use some tracking of the jerry cans to better understand where they are going across this 1 month of peak, and trying to understand what type of source and how this source is used by the community. Is it a shared one? What is the type of sources? And the idea of this is we were seeing, and more specifically, a lot of salmonella in water sources in the one that were shared with livestock. We were also seeing salmonella in some of the borehole, and that was linked to the depth of the borehole and where the water was fetched. And because some of the underground water they were trying to fetch, it was definitely more considered as surface water than underground water. So there has been some infiltration and link with this.
Yes, thank you very much. I think that marks the end of our session this afternoon. We want to thank the presenter for preparing and making very good presentation. And yes. And the audience for coming and leading to a very good scientific discussion. Until next time, thank you very much.